Okay, so we have talked about proportional and non-proportional relationships, and we do know that a proportional relationship is a straight line that goes through 0, 0, and 0, 0 also known as the origin. And we write that proportional relationship as y equals kx. If you remember from our notes last Thursday, the k in this situation is still the same as your m, as your slope. And we are going to be having some conversations and maybe a poster up in the room talking about all the different ways we refer to slope, because we know it has a lot of names. So direct variation, though, is just another way you can refer to proportional relationships. So anything that has direct variation is a proportional relationship. So if you have something that does not have a y-intercept, which is what a proportional relationship is, goes to 0, 0, then that equation or that situation does have direct variation. So anything that is proportional is also has direct variation, okay? And I'm writing this again for the y equals kx to put in the box, because we want you to know that you can read this as y varies directly with x. So anytime you see a term like varies directly, you know that that's going to have an equation you can set up like this here from a table or from a graph, and we'll go through the labels on that also. That's going to be a video posted in your notes. In this equation, k is going to be our slope, and we're looking at it just as a ratio of y to x. So if we were looking at different situations, like if you were discussing the number of hours you worked in a table and the amount of money you were paid, you would say that y varies directly to x. So the amount of money you paid would go on top of a ratio, and the number of hours you worked would be on the bottom. And like I said up here, all the different things we can call for slope. Slope is also called a constant of variation. And that's because it varies constantly. Like it's, there's no change from one to the next. You use the same, sorry, I meant to write the wrong word there. You use the same slope, the same number, whatever it is, to vary constantly. And it's also called, you'll see it referred to as the constant of proportionality. Okay, so looking at some examples here to see what this actually means. This little situation here is talking about glue sticks and number of students, okay? Or the glue sticks and the cost per them, sorry, I'm on the wrong one. So it says the total cost for glue sticks varies directly with the number of glue sticks purchased. So if 10 glue sticks cost $5, we're gonna identify the constant of variation and write an equation to represent the relationship. Well, we know this is our K, or slope. Okay, so we're looking for slope in this equation. So if we're looking at what varies directly with the other, when you see the words varies directly, whatever is to the left of it will be your y. So y is talking about total cost. So our y is going to represent the total cost, and varies directly to the whatever is to the right of it is going to be my x, the number of glue sticks purchased. Okay, so if we're looking at a ratio of y to x, we know that 10 glue sticks, and 10 x goes glue sticks, that's on the bottom, so 10 glue sticks on top are $5. Okay, so if we wanted to find the constant of variation, we know that this is our slope, so we are just going to take that fraction and put it into alpha y equals to simplify it. And we'll put it in as 5 over 10. And that gives our slope as 1/2. Our constant of variation is 1/2. Since this is money, though, I'm going to say 1/2 is also equal to 0.5. So we'll say it's 50 cents. So if I wanted to write this in an equation, I know my equation is y equals kx. Sorry, I'm looking for it up here. Y equals kx. So I'm going to put y equals, here's my k. You can write it as 1/2 or 0.5. Y equals 1/2 x. And that is our equation. So if you're looking at it in a proportion standpoint, like you need to solve for a specific number, we're going to set it up the same way as we do right here. Only this time they're going to give us a third number, and we're going to solve for it. Okay, so it says the number of teachers varies directly to the number of students. So I know that to the left of this will be number of teachers, so that's going to be my y. And to the right of this is the number of students, so that will be my x. Okay, so if there are 4 teachers for 88 students, so I've got 88 students and 4 teachers. Well, students is going to go on the bottom. Teachers go on the top. So if I'm looking for how many teachers there are for 1,474 students, this is my third number I was saying they gave us. Well, we also know what it's talking about. It's talking about students, and we know that students goes on the bottom. So if we are looking for how many teachers, we don't know that. That's kind of my question mark there. So I don't know if you remember from 6th grade or 7th grade to solve proportions, we do this little circle and box or cross multiply, butterfly, whatever you call it. So what you're going to do with your numbers in the circle is you're going to multiply 1,474 times 4, and then I divide by the number in the box. And that tells me that I'm going to need 67 teachers for that trip. So if I wanted to write this in an equation, this is my k here, the 4/88, and I would need to simplify that to get my actual slope. So I would go to alpha y equals again, 4/88, and my ratio of teachers to students is 1 to 22. So since this is my k, then I'm going to write it as y equals kx, y equals 1/22x. And that's all. Okay, let's look at one more example. The number of treats given in a vet's office varies directly with the number of dogs that come to the office. So I know to the left of that, they are talking about the number of treats. And to the right of that, they're talking about the number of dogs. So I'm going to have y equal treats, and x is going to equal dogs. And it says 18 treats were given out for the 9 dogs that came. So 18 and 9. 18 goes with treats, so it's going to go on top. 9 is with dogs, so it goes on the bottom. And our question is, how many dogs came to the office if they gave out 14 treats? So I know that treats goes on top, so that's where my 14 will be. And even though in this situation, our variable that we did not know was on top, we're still going to solve it the same way. Okay, so I would circle my numbers that are across from each other and box what's left. And again, I'm just going to multiply what's inside the circle, 14 times 9, and divide by 18. And that tells me that 7 dogs came into the office that day. Okay, if again I wanted to put this into an equation, I would just take my k right here and tap it into alpha y equals to simplify. And that gives me a whole number of 2. So my equation, y equals kx, will be y equals 2x. And that's kind of all there is for direct variation.